Hi there, welcome to Ethio-Hahu tutorial. Today we are going to see about projectile motion. And in this class we are going to see about the definition of projectile motion, parameters that can characterize projectile motion, and we'll do some examples. A projectile is any body that is given an initial velocity and then follows a path determined by the effect of gravitational force and air resistance. In this case, we are going to see different assumptions. The first assumption is acceleration due to gravity g is constant over the range of motion and directed vertically downward. The second assumption, we neglect the effect of air resistance. Third, the rotation of the Earth does not affect the motion. Having this assumption, consider a body projected with an initial velocity v0 at an angle of departure theta naught, like this. A particle is projected with an initial speed v0 that makes an angle theta naught with the horizontal. Therefore, this is the trajectory of the projectile motion. On its trajectory, the only net force acting on this projectile is gravitational force, which is directed vertically downward, ignoring air resistance. The vertical component of the velocity of the projectile motion is affected by the gravitational force, whereas the horizontal component of the projectile remains constant. Therefore, as you can see, at every point on its trajectory, the x component should be constant. Here, v0 x is the initial velocity of the projectile along the x-axis. The component of v0 along the x-axis is v0 x. The component of the initial velocity along the y-axis is v0 y. This v0 y changes with time as the particle follows this path, whereas v0 x remains the same because there is no net force acting along the horizontal direction. At the maximum point of its flight, the y component of the velocity becomes 0 because as it moves higher and higher, its velocity, its vertical velocity actually, gets decreased and decreased, so that the y component of the velocity at the highest point is 0, whereas the horizontal component of the velocity remains constant. The x component of the velocity remains constant in this case because there is no net force acting on the projectile along the horizontal direction. The question is the vertical motion affected by the horizontal motion and vice versa? Can the vertical motion be affected by the horizontal motion, or can the horizontal motion is affected by the vertical motion? This is the question. Since the vertical motion and the horizontal motion are independent of each other, one cannot affect the other. Therefore, the horizontal and vertical motions are mutually independent. So, the equations describing the motion of the projectile can be written separately. With this, let's consider the horizontal component. In the horizontal component, the net force acting on the projectile is 0. This means net force. Since the net force acting on the projectile is 0, the acceleration of the projectile along the x-axis is 0. Acceleration 0 means either v is equal to 0 or vx is equal to constant. Therefore, the x component of the velocity remains constant. That means vx of t is equal to v0 x, and this v0 x is v0 times cosine of theta because the projectile motion is this one. This is the initial velocity of the projectile. This is the angle it makes with the horizontal. The x component is v0 x and the y component is v0 y. v0 x is simply v0 times cosine of theta naught. That's why the x component of the velocity of the projectile at any instant of time is v0 times cosine of theta naught, which is constant. X of t, the horizontal displacement of the particle at any time t is given by x naught plus v0 times cosine of theta naught times t. This is the displacement along the x-axis at any instant of time. When we come to a vertical component, along the vertical direction, there is net force acting on the projectile, and that net force is gravitational force, and this gravitational force is the only net force acting along the vertical direction on the projectile. Due to this net force acting along the vertical direction, the projectile has a vertical acceleration, AY, is equal to acceleration due to gravity minus G, because this is the projectile motion, V naught, theta naught, and this is the trajectory of the projectile. This one is V naught X, this one is V naught Y. At its trajectory, the only net force acting on the projectile is gravitational force. That's why the vertical component of the projectile motion has acceleration AY is equal to minus G. Why minus G? Acceleration due to gravity is vertically downward. This is y-axis, but acceleration acts in the negative y direction. That's why this negative sign shows that acceleration due to gravity is vertically downward. The velocity of the projectile at any instant of time, Vy of t is equal to Vy of t is equal to V naught sine theta naught minus gt. This can be obtained from this. V final is equal to V initial plus a times t. Vy at any instant of time is equal to V naught y plus acceleration along the y-axis times t. In this case, V naught y is along the positive y direction, positive, that is V naught times sine theta naught, but acceleration along the y direction is vertically downward to the negative y direction, and that is equal to minus g times t. Therefore, the y component of the velocity at any instant of time is V naught sine theta naught minus gt. The displacement at any instant of t along the y direction is equal to y naught plus V naught sine theta naught t minus half gt squared. This means y of t is equal to y naught plus V naught y times t plus half times ay t squared. This is equal to y naught plus V naught y is V naught sine theta naught times t. Ay is minus g times plus minus 1 over 2 times g times t squared. This is the displacement of the particle or the projectile along the y direction at any instant of time. Having seen this, let's find the time required to reach the maximum height when the projectile is projected at some angle theta naught. At the maximum point, Vy is 0, but we have Vx. Vx is equal to V naught x. V naught x is the initial component of the velocity along the x-axis. V naught x is equal to V naught times cosine of theta. But Vy is 0 at the maximum point. The time required to reach this maximum height, Hmax, is obtained from the vertical component of the velocity of the projectile at any instant of time. Vy at any instant of time is equal to V naught sine theta naught minus g times t. This is the velocity of the particle or the projectile at any instant of time along the y direction, because at every point we have Vx and Vy. Here Vx and Vy and so forth. At the maximum height, at Hmax, the y component of the velocity is 0. At Hmax or Ymax, Vy of t is equal to 0. This implies, from this equation, 0 is equal to V naught sine theta naught minus gt. Let's bring minus gt to the left. G times t is equal to V naught sine theta naught. Divide both sides by g. T is equal to V naught sine theta naught divided by g. This is the time required by the projectile to reach Hmax. The time of flight is Tf is equal to twice of the time taken to reach Hmax, t. This is equal to time taken to reach Hmax is V naught sine theta naught divided by g. 2 times V naught sine theta naught divided by g. This is the time required by the projectile when the projectile is in flight. This time of flight can be obtained also from this equation, from the displacement of the particle along the y direction at any instant of time. Y of t is equal to y naught plus v naught sine theta naught times t minus half gt square, because the particle is projected from this point and reaches this point. This is the final point. Therefore, the initial point and the final point are the same. Y of t is 0. This is 0. That's equal to y naught is also 0, the reference point. 0 plus v naught sine theta naught times t minus half gt square. Let's bring minus half gt square to the left. Half times gt square is equal to v naught sine theta naught times t. Multiply both sides by 2 and divide by g. T square is equal to twice of v naught sine theta naught times t divided by g. But here we have 1t, here we have 2t. 1t goes with 1t. T is equal to twice of v naught sine theta naught divided by g. This is similar to this one. This is time of flight. This time of flight. When t is equal to time of flight, the displacement along the y direction is 0. Therefore, time of flight is twice of v naught sine theta naught divided by g. And time taken to reach h max is v naught sine theta naught divided by g. And the time of flight, tf, is twice the time required to reach h max or y max. That is 2 times v naught sine theta naught divided by g. Having seen this, let's find the maximum height, h max. How can we find h max? Again, h max or y max. This is theta naught, v naught x and v naught y. To find h max, the displacement y of t at any time t is equal to y naught plus v naught sine theta naught times t minus half gt square. This is the displacement of the particle along the y direction at any instant of time. But time taken to reach h max, time taken to reach h max is equal to y max is t is equal to v naught sine theta naught divided by g. And let's substitute for t v naught sine theta naught divided by g. And y naught is 0, the reference position. This is 0. Therefore, y of t is equal to v naught sine theta naught times t minus half gt square. To find y max or h max is equal to v naught sine theta naught times t is v naught sine theta naught divided by g. V naught sine theta naught divided by g minus 1 over 2g into v naught sine theta naught divided by g the whole square. This implies y max or h max is equal to v naught times v naught square sine square theta naught divided by g minus 1 over 2 v naught square sine square theta naught divided by g. Here g square, 1g goes with 1g and we are left with g. This is equal to v naught sine square theta naught over g minus half of v naught square sine square theta naught over g is v naught square sine square theta naught divided by 2g. This is h max or y max. On the other hand, we can find vy square is equal to v naught y square minus 2 times g times h or y. At h max, vy is equal to 0. Therefore, if we substitute 0 for vy, 0 square is equal to v naught sine theta naught the whole square minus 2 times g times h max. When h is equal to h max, Vy is 0. Let's bring minus 2g h max to the left. 2g h max is equal to V naught sine theta naught square means V naught square sine square theta naught. Divide both sides by 2g. Therefore, this implies h max is equal to V naught square sine square theta naught over 2g. Therefore, h max or y max is equal to V naught square sine square theta naught divided by 2g. To find the range, the maximum horizontal distance r is equal to x max. Range is equal to x max is equal to V naught square sine theta naught divided by g. This means this x-axis, this y-axis, this is V naught, this is range, x max or range, this theta naught, this is V naught x. The time required by the projectile to move from this point to this point is Tf, twice of V naught sine theta naught divided by g. X max, then x max is equal to V naught x times Tf, because V naught x is the same as Vx. V naught x is V naught cos theta naught times Tf is twice of V naught sine theta naught divided by g. This is equal to V naught times V naught square, 2 times sine theta naught cos theta naught, 2 times sine theta naught cos theta naught divided by g. But what is 2 sine theta naught cos theta naught? Sine of alpha plus theta is equal to sine alpha cos theta plus cos alpha sine theta. If alpha is equal to theta, then sine of theta plus theta is equal to sine of 2 theta, which is equal to sine of alpha. For alpha, substitute theta, sine of theta cos theta plus substitute for alpha cos theta sine theta. Therefore, sine theta cos theta plus sine theta cos theta to sine theta cos theta. Therefore, 2 times sine theta naught cos theta naught is sine of 2 theta naught divided by g. This is x max or range. The range of a projectile is V naught square sine of 2 theta naught divided by g. The other one, let's combine the horizontal and vertical motion. R of t is the instantaneous position of the projectile at any instant of time. R of t is equal to x of t in the I plus y of t in the j. But in this case, x of t is simply x naught plus V naught cos theta naught times t. Y of t is equal to y naught plus V naught sine theta naught times t minus half of g t square. Substitute for x of t, this one, x naught plus V naught cos theta naught times t, this one, in the I, plus for y of t, y naught plus V naught sine theta naught times t minus half gt square, this one. For v, v of t is equal to vxi plus vy of t in the j. But vx means vx at any instant of time is equal to v naught cosine of theta naught. Vy at any instant of time is equal to v naught sine theta naught minus gt. Let's substitute for vx and vy. Vx is v naught cos theta naught in the I, this one, plus vy is v naught sine theta naught minus gt in the j. This is the instantaneous velocity of the projectile motion, and this is the displacement of the projectile at any instant of time. Since y of t is equal to y naught plus v naught sine theta naught t minus half gt square, and x of t is equal to x naught plus v naught cos theta naught times t, and assuming that x naught is equal to 0, the initial position of the projectile along the x-axis there is 0, then since x naught is 0, solve for t. T is simply x of t divided by v naught cos theta naught. From this expression, if x naught is equal to 0, x of t is equal to simply v naught cos theta naught times t, and solve for t. T is equal to x of t divided by v naught cos theta naught, this one. And substituting this value into this, y of t is equal to simply v naught sin theta naught times t. For t, substitute this, x of t over v naught cos theta naught minus half of g into t square is x of t square divided by v naught square cos square theta naught. Y of t, actually here we have y naught. Y of t is equal to y naught plus v naught goes with v naught, this one, sin theta naught over cos theta naught tan theta naught times x of t minus g over 2 v naught square cos square theta naught times x of t square. Therefore, rearranging this, y of t is equal to minus g over 2 v naught square cos square theta naught times x square plus tan theta naught x plus y naught. This is a kind of polynomial equation of degree 2. This is the relationship between the vertical displacement and horizontal displacement, y of t and x of t at any instant of time. Having seen this, let's see example. Example 1. A rescue plane drops a package of emergency rations to stranded hikers as shown below. The plane is traveling horizontally at 40 meters per second at a height of 100 meters above the ground, neglecting air resistance. Where does the package strike the ground relative to the point at which it was released? B. What are the horizontal and vertical components of the velocity of the package just before it hits the ground? And finally, what is the angle of impact? This is a rescue plane. This rescue plane is initially moving at 40 meters per second horizontally and drops a package of emergency rations. When this emergency package is dropped from the rescue plane, it has a horizontal initial velocity of 40 meters per second because it was initially moving with the plane. That's why the package of this emergency rations has horizontal component of the velocity 40 meters per second, but the y component of the velocity is 0. To do this, for the package v naught y is 0 because when the package is dropped from this elevation point, the y component of the package is 0. But the horizontal component of the package is similar to that of the velocity of the plane. V naught x is equal to simply velocity of the plane. That is 40 meters per second. What about y naught? If we take this is our reference point, y naught is the height of the emergency package ration. That is 100 meters. Therefore, how far does this emergency package hits the ground horizontally from the point of impact? That's what A says. A, x of t. X of t is this one. To find x of t, this horizontal distance, first we need to find the time required to move this x. The time required to move this x is the same as the time required to drop this 100 meters. Therefore, from the vertical motion of the projectile, y of t is equal to y naught plus v naught y times t minus half gt square. This implies y of t is equal to y naught plus v naught y 0 because v naught y is 0. Therefore, we are left with minus 1 over 2 gt square. Y naught is 100. When the package reaches this point, the final position of the package along the vertical is 0. Therefore, this is equal to 0 is equal to y naught is 100 meter. This is 100 meter minus 1 over 2 gt square. Let's bring this one to the left. Half of gt square is equal to 100. This is equal to half of g is 10 times t square is equal to 100. By 1 by 2, 5. 5t square is equal to 100. Divide both sides by 5. T square is equal to 20. And t is equal to the square root of 20. This is equal to 4.47 seconds. This is the time required by the projectile to drop this 100 meter and the time required to move this horizontal distance x. Therefore, x is equal to v naught cos theta naught times t, and this is equal to v naught x times t. V naught x is 40 meters per second because it is similar to that of the velocity of the plane, 40 meters per second times time 4.47 seconds. This is equal to 178.8 meter. B, the horizontal and vertical component of the velocity. The horizontal component of the velocity and vertical component of velocity. Vx is equal to v naught x, which is equal to 40 meters per second, because along the horizontal direction there is no net force acting on the package, so that the horizontal component of the projectile motion is constant motion. Vy is equal to simply v naught y minus gt. V naught y is 0, this is 0, is equal to minus 10 meters per second square times time is 4.47 seconds. 1 second goes with 1 second. Minus 10 times 4.47 is equal to minus 44.7 meter per second Vy. Therefore, the horizontal component and the vertical components are this one. This is horizontal component and this is the vertical component of the velocity. See the angle of impact. When this package hits the ground at this point, it has this speed, v. But this v has x component, vx, and y component, vy. And this is the angle of impact, theta, that we are going to find. To find this theta, tan theta is equal to vy over vx. Vy is minus 44.7 meter per second. Vx is 40 meter per second. Meter per second goes with meter per second. Theta is equal to tan inverse of minus 44.7 divided by 40. And this is equal to minus 48.2 degree. Here the negative sign shows that the angle is below the x-axis. Here the negative sign shows that this angle is below the positive x-axis. Example 2. A police officer is chasing a burglar across a rooftop. Both are running at 4.5 meters per second. Before the burglar reaches the edge of the roof, he has to decide whether or not to try jumping to the roof of the next building, which is 6.2 meters away but 4.8 meters lower. Can he make it? Assume that he jumps horizontally. Here, this is a burglar and here is the police officer. Both are running at 4.5 meters per second. The next building is 6.2 meters away from this building and 4.8 meters below this building. In this case, V naught y is 0 because we are told that the burglar jumps horizontally. Therefore, V naught y is 0. The initial velocity of the burglar along the y direction is 0. But V naught x is simply Vx, 4.5 meter per second. If we take this as a reference point, y naught is 0 because the displacement of the burglar from the reference point along the y direction is 0. Y final is minus 4.8 meter because the burglar moves 4.8 meter down the next floor. Therefore, y is equal to y naught plus v naught y times t minus half gt square. Y is minus 4.8. This is equal to y naught is 0. This is 0. V naught y is 0. 0 times 10 number, 0. This is equal to minus half times g is 10 times t square. Negative goes with negative. 4.8 by 1 by 2, 5. T square is equal to 4.8 divided by 5. And t is equal to the square root of 4.8 divided by 5. And this is equal to 0.98 second approximately. This is the time taken by the burglar to drop 4.8 meter from this point vertically downward. Having this time, let's calculate the horizontal distance traveled by the burglar. X at any instant of time, that is the horizontal distance moved by the burglar, is simply V naught x times t. Here V naught x is the same as 4.5 meter per second times time 0.98 second. Second goes with second. 4.5 times 0.9 is simply 4.41 meter. This is the horizontal distance moved by the burglar. Therefore, with this initial velocity, the burglar moves horizontally 4.41 meter. However, the horizontal distance of the next building from the first building is 6.2. Because of this is 6.2. But when the burglar attempts to jump to this floor, he has to jump a maximum horizontal distance of 4.41 meter. Therefore, he cannot reach the next floor. Therefore, our advice is not to try to jump to the next floor. That is what our advice is. And this is all about projectile motion. In the next class, we are going to see about circular motion.